while ago. You wanna know how?
Yes.
Come by to this classroom tomorrow. I'll show you.
Sure.
Yeah. Hey Lance, can you now teach me how to shoot?
Okay, bro. So this is how you will do it.
You might be asking, what was that? Why did you show someone shooting balls through a ring with strings attached to it? Well, simply put, those are examples of projectile motion, which we are going to discuss in today's video. First, we discuss the terms. What is a projectile? A projectile is any object that's given an initial velocity and then follows a path determined entirely by gravitational acceleration, regardless of whether you're launching a balloon, a baseball, or an arrow. All projectiles follow a predictable path, making them a great tool for studying kinematics. Secondly is motion. What is motion? Motion is in any sense the process of movement. Thirdly, projectile motion. Projectile motion is a predictable path traveled by an object that is influenced only by the initial launch speed, launch angle, and the acceleration due to gravity. Pick up an object and gently toss it up and away from you. It will rise as it flies away from you, reaching a maximum height and then starts falling down to the floor. Here are some key points to remember about projectile motion. Projectiles follow a predictable parabolic path depending on how hard or how high you throw the projectile. The path could be stretched out or high and steep, but it will always be a parabolic shape. And once forced into motion, the projectile is only acted on by gravity, ignoring any impacts of air resistance. Of course, when given problems on projectile motion, you won't be able to answer them without the formulas. And here are the formulas. Firstly, is x equals vi cosine theta t. X is the x component, vi is the initial velocity, cos theta is the cosine angle, t is the time. Secondly, y equals vi sine theta t plus 1/2 gt squared. Y is the y component, vi initial velocity, sine theta the angle, g gravity, and t is time.
Now, for the next one, Vfy is equal to Vi sine theta plus gt, where Vfy is the velocity final, and Vi is the initial velocity, while sine theta is the angle, g is the gravity, and t is time.
2gy equals Vfy squared minus Viy squared. 2gy means gravity, while y means the y component. Vfy means velocity final, and Viy means the initial velocity. Fifthly, t equals negative Vi sine theta over g. T means time to reach maximum height, while negative Vi means the initial velocity multiplied by sine theta, the angle, over g gravity. This formula can also be used to find the total amount of time of the parabolic path by multiplying it by 2. Sixthly, y equals negative Vi squared sine squared theta over 2g. Y means the maximum height, Vi initial velocity, theta the angle, 2g gravity. Here's another formula for finding the maximum height, which is y equals negative Vi y squared over 2g, wherein y is the maximum height.
Did you understand our explanation? Well, here are 2 examples about projectile motions that you can try. For the first problem, a US military aircraft has been reported to be traveling 72.5 meters on the skies of Iraq, which is 235 meters above the ground. It decides to drop a package to a nearby military camp, and to reach the camp accurately, how far must the plane be before dropping the package? Now, you can pause the video first if you want to solve it or not, but we're gonna show the solution anyway. Now, for the solution of the problem, we're going to use two formulas. The first formula is x equals vi cos theta t. Since the angle is 0 degrees, cos theta is now equal to 1, which leaves us to the formula of VIT, and VI is 72.5 and T is missing. Now to get T, we're going to use the other formula, which is y equals VI sine theta T plus 1/2 GT squared. Since sine theta, sine 0 is equal to 0, we're going to cancel that out and get y equals 1/2 GT squared. Now, in this formula, we're going to derive to get T, which is now square root of 2y over g. And that is the formula of T, and that's what we're going to put to the first formula. So x equals vi times the square root of 2y over g. Putting the values is now equal to 72.5 times the square root of 2 times negative 235 over negative 9.8. Now in this formula, we're going to get the value of x, which is now approximately 508.02 meters. Got the answer? Good job. Here's another problem. Billy decides to throw a ball on top of a building with a height of 55 meters, and the ball landed 35 meters away from the building, and the angle was given is 0 degrees. Now there are two things that you need to solve here. First, what you need to solve is the time that it hits or reaches the ground, and second is the initial speed of the ball. Now you can pause the video if you want to solve it first, or not, depending on yourself, but we'll show the solution anyway. Now, for the solution of the problem, for the first question, we're going to use the formula of y equals vi sine theta t plus 1/2 gt squared. Since sine theta is equal to 0, we can cancel that out and leaves us to 1/2 gt squared. And in here, we're going to get the formula of t, which is now square root of 2y over g. Putting the values is 2 times negative 55 over negative 9.8, and leaves us to the answer of t, which is approximately 3.35 seconds. If you got it, good job. Now, for the next question, we're going to use the formula of x, which is equal to vi cos theta t. Since cos theta is equal to 1, that leads us to x equals vit. Now, in that formula, we're going to solve for vi, which is now vi equals x over t, and putting the values, we'll get 35 over square root of 2 times negative 55 over negative 9.8, and vi is equal to 35 over 3.35, which is now approximately 10.45 meters per second. Good job if you got the correct answer.
Thanks, bro. I finally get it.
Sure, bro, no problem.